Let's talk about traffic flow. According to Dr. Schrader's slides, traffic flow is the study of the movement of individual drivers and vehicles between 2 points and the interaction they make with each other. It's very important to basically study traffic flow because our design is all based on flow, on traffic and flow basically. Why is it important? Because it's very important for design. It's probably one of the most important element of design. The flow can determine how many lines do we need in a road. Should we have a roundabout or not? And all of these kind of things depends on the flow itself. So traffic flow is very, very, very important. Personally, like when I look to traffic flow, it just seems like one of these subjects that really feels like transportation, it feels like traffic engineering. It doesn't feel like psychology. So it's really kind of like the first, probably the first topic when it comes to traffic engineering that probably does not directly involve another field like psychology. When it comes to traffic flow, it's very important to take into consideration some of the aspects that could affect the traffic flow. Okay, for example, when we want to analyze the traffic flow, for example, we gotta look at the certain road, whether it's a two-lane road or non-two-lane road, whether it's whether it's a one-way road or or two-way road. Traffic flow is very important because traffic flow basically is just like flow in the body. You don't want to overflow your body with blood because you're going to end up with a high blood pressure. And as we all know, that's not healthy. Same thing with the roads. You don't want to overflow your highway with more cars than its capacity because you're going to end up with a traffic jam. You're going to end up with all these kind of problems. Maybe your probability of having accidents is going to increase, and you end up with a less efficient design. So that's why traffic flow is very important. One of the ways that we regulate traffic flow is using signals, signs, like light signal is probably one of the most common way to regulate traffic flow. Stop signs as well. If if they are used properly, if they are not used properly, probably they can end up actually causing more problems than fixing the problem, which could be another issue to be solved. I would like to mention this as a side note. Actually, it's an interesting point I was just thinking of right now. When we compare traffic flow to water flow in pipe, usually when we reduce the diameter in a pipe, we increase the velocity increases and the pressure decreases. It feels it kind of like the opposite with roads. Like let's say if we abruptly went from 2 lanes to 1 lane, it slows down the traffic and kind of increase the pressure, aka the headache, which I thought that was interesting. In traffic flow, when it comes to numerical calculations or numerical values to running calculations, there are three important characteristics of traffic. Uh, One is the flow itself. We call it Q, which is like a vehicle per unit time. We have density. We use a simple K for density, which is like vehicle per unit space. And we have speed. We use V, well, speed or velocity, which is unit space per unit time. There are some more factors that we need to consider for traffic flow. One of them is time headway, HT. Basically is using Dr. Schrader's PowerPoint, It's the difference between the time when the front of a vehicle arrives at a point on the roadway and the time the front of the next vehicle arrives at the same point in seconds. Basically, it's the gap between the two vehicles, the gap of time. We use the front of the vehicle probably just as because okay, it's a convenient reference point rather than using the middle of the vehicle or the end of the vehicle, especially like when it comes like to the vehicle length. Some vehicles are taller than others, so probably choosing the front of the vehicle makes more sense or makes things more easier, more accurate. And we have the space headway HS as well, which is the difference in position. Time headway was the difference in time, but space headway is difference in position between the front of the vehicle and the time the front of the next vehicle arrives at the same point. This basically, okay, once the first vehicle hits that point, the space headway basically is the distance between between vehicle number 1 and vehicle number 2 that's going to hit the same point that vehicle number 1 hit. Let's talk about queuing. According to Fundamental of Transportation, and I'm using Dr. Schrader's slides again, queuing is the study of traffic behavior near a certain section where demand exceeds available capacity. Queues can be seen in a variety of situations and transportation systems. Its presence is one of the causes of driver delay. Basically, imagine you have a water storage tank and something is slowing down the outflow of the water only to slow down the inflow of the water. That's what queuing basically is. As I have mentioned before, queuing happens when the demand exceeds the available capacity. Take a car jam, for example. The demand exceeds the available capacity in a car jam, which results in the delay. Another example would be at a road tollway where we may have some delay in the vehicle flow. Same thing can be said about restaurant drive-through. Now, for both examples, the road tollway and restaurant drive-through, we can divide our queue time into service time and delay time. As traffic engineers, we try our best to make sure our design doesn't cause so much delay time. As for the service time, in a restaurant, I would say it's all about the restaurant itself and how they provide their service. I think this is something should be done internally rather than externally. But from a traffic engineer standpoint, we should make sure the design when it comes to entrance, exit, size, geometric design and size, we have to make sure it doesn't cause any unpleasant delay. Let's talk about shockwave theory. Let's say you are driving down a one-lane road and you were the first car to stop for traffic signal, so you were first in line. Now, let's say there were 9 cars behind you. Basically, they arrived after you arrived, so they had to stop because of the red signal. As the signal switched to green, 3 more cars arrived, so they did not have to wait like the other 10 cars. So they became the lucky ones. Basically, that's the shockwave theory. We try to analyze like how many cars stopped, how many cars did not have to stop, who's the lucky one, who's not the lucky one, and we try to analyze and see. Basically, we try to use these data to improve our traffic quality. Now, there are so many types of shockwave theories and so many books probably can use. They are frontal stationary, backward forming, backward recovery, rear stationary, and forward recovery shockwaves. All these are shockwave theories, basically.